guys, and welcome to Lighthouse Engineering. Before we can begin with today's lesson, can you please like, subscribe if you haven't subscribed yet, and just leave a comment at the end of the video so that I can answer any questions or any queries that you might have. So, without further ado, let's get going. So, I'll be continuing with what we've done last time, which was acceleration, and I'll do one of three examples that I will be doing today. So our main focus will be using areas to find distances and displace. Okay, that's terrible. Displacements. Okay. So if you haven't watched my previous videos, please go check them out so that you can see the difference between these two and how can you tell the difference between these two guys right here. They don't mean the same thing actually. So let me give you an example why we need to bother ourselves with finding the area, because that could prove a very big problem. Now, as you can see, that would be a problem because some types of graphs will be able to move like this if the velocity is increasing up to a maximum, or the velocity is staying constant, or it has a gradient like this shape. So now how do you find the distance traveled, or maybe the displacement traveled? Well, first of all, we need to know the area. This one is simply a triangle, which is going to be half base times the height. And this one would be simply become a square. So the area of this one would be just the base, you multiply by the height. And this one is a trapezoid. And the trapezoid's area would be equal to half the parallel sides, which is V1 and V2, sorry about that, multiplied by the distance between those parallel sides, which is T. So what do we do with all of this? Now I'll show you in my first example how we can take advantage of this. Now on example 1.1, we are being asked how far does Tom cycle? Now if you can read through the problem, which is the graph shows Tom's journey from the time he turns on the main road until he arrives home. So how far does Tom cycle? And as you can obviously see, this graph has quite a number of areas, of shapes inside it. We've got an area under P, area Q, and area R. So to get how far did Tom travel, we need to combine all of these areas into one. Please take note that it's a speed versus time graph, meaning that the speed, it's only a scalar quantity. It actually has no direction. So let me get to it. So we first need to know the area at P. What's the area at P? That will be equal to half, since it is a trapezoid. Half, what are the parallel sides? It's 4 units plus 10, multiply the distance between them, which is 6, and that will give us 42 meters. And now we want to know the area at Q. Q is simply a square, which is gonna be, sorry, this is simply a square, which means it's just gonna be the base times the height, which is just 10, multiplied by 20 units, which is going to give us 200 meters. Also the area at R, which is what? Which is also a triangle. Luckily for us, these are really nice and easy shapes, which is equal to 10 times 4, and it will give us 20 meters. Now, if you combine all of this, that means Tom traveled a total distance of 262 meters.